Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2121, is associated with the Accelerator Pedal Position, APP, sensor A, specifically the Throttle Position, TP, sensor D. This code indicates that the signal received from this sensor is out of the expected range. The APP sensor is a critical component in determining how much power the engine should produce based on the driver's input via the accelerator pedal. It is located in the lower dash area, directly connected to the accelerator pedal module. This sensor communicates with the powertrain control module, PCM, which interprets the data to manage engine performance and throttle response. When the APP sensor signal is in an abnormal state, it can lead to poor engine performance or even safety concerns, making it essential to address this DTC promptly. DTC P2121 signifies an issue with the APP sensor A, responsible for relaying the position of the accelerator pedal to the PCM. This sensor is essential for ensuring that the engine responds correctly based on accelerator input. It helps manage the throttle angle and affects acceleration, fuel efficiency, and emissions. The APP sensor is situated near the accelerator pedal assembly in the vehicle's footwell. If the signal sent to the PCM is either too low or too high, the vehicle's performance can be compromised. Therefore, understanding the relationship between the accelerator pedal position and engine management becomes crucial in diagnosing this DTC. Several factors can lead to DTC P2121. Poor electrical connections or loose terminals at the APP sensor and PCM can interrupt the signal flow, causing incorrect voltage readings. These issues often arise from corrosion, wear, or stress on the wiring and connectors, leading to intermittent failures. Moreover, a faulty APP sensor itself could be the root cause. Physical wear or internal faults within the sensor may disrupt its functionality. Lastly, issues within the PCM can also manifest as failures in sensor readings. It's essential to systematically evaluate these potential causes to correctly identify the underlying problem. Common symptoms associated with DTC P2121 include engine performance issues, such as hesitation during acceleration or an unresponsive throttle. The vehicle may not accelerate as expected, significantly impacting drivability. Drivers may also notice warning lights on the dashboard, particularly the check engine light, indicating an underlying issue that needs attention. In severe cases, the engine may enter limp mode to prevent further damage, leading to even more noticeable changes in performance. Recognizing these symptoms is crucial for timely repairs and to avoid safety risks while driving. Begin troubleshooting DTC P2121 by turning the vehicle to the on mode and utilizing the Honda Diagnostic System, HDS, to check the voltage of APP sensor A. According to specifications, the expected voltage should be 0.69 volts or lower. Compare the current reading to this threshold to determine if it falls within the appropriate range. If the voltage matches, it indicates that the fault has been confirmed, and you should proceed to step 3 for further diagnostics. If the voltage does not match, move on to step 2, where you'll check for higher voltage conditions and potentially identify intermittent faults. In troubleshooting step 2, recheck the APP sensor A voltage using the HDS. This time, look for a voltage reading of 4.99 volts or higher. If this condition is met, it confirms that the fault is duplicated, prompting a move to step 8 for further investigation. However, if the voltage reading does not meet this threshold, it may indicate an intermittent failure. During this scenario, Inspect the wiring and connections for any loose terminals or poor connections at both the APP sensor and PCM connectors. Identifying these issues may resolve the DTC without extensive repairs. For troubleshooting step 3, turn the vehicle off and disconnect the APP sensor 6P connector. Next, switch the vehicle to the on mode to measure the voltage between specific test points in the connector. The target is approximately 5.0 volts when measured at the connector's female terminals, specifically those corresponding to test points 1 and 2. If this expected voltage is present, proceed to step 4 to investigate further. Conversely, if the voltage is not seen, it may indicate a problem with the circuit or connections, warranting further examination in step 7. In this step, start by turning the vehicle off and using the HDS to jump the SCS line, allowing it to sit for over a minute. Then, disconnect the PCM connector A and check for continuity between the test points involved, ensuring the APP sensor connector is also disconnected. This step specifically assesses the APS1 line for potential shorts that may affect voltage readings. If continuity is found between the specified test points, it indicates a short in the APS1 wire that requires immediate repairs. If no continuity is detected, it suggests that the APS1 wire is intact, leading to the next troubleshooting step. Step 5 involves connecting terminals A and B of the APP sensor 6P connector with a jumper wire, while keeping the PCM connector and the APP sensor 6P connector disconnected. This is done to check for continuity in the APS1 line between the PCM and the APP sensor. When continuity exists, it confirms that the APS1 wire is functioning correctly, allowing you to move to step 6. If no continuity is detected, this indicates an open circuit in the APS1 wire that needs to be repaired, as it is essential for the APP sensor's proper operation and ensuring accurate readings are sent to the PCM. Step 6 starts with removing the jumper wire from the APP sensor 6P connector and reconnecting the PCM connector A. Next, use another jumper wire to connect 2 specified terminals of the APP sensor connector while turning the vehicle to the on mode. Check the APP sensor A voltage using the HDS. A voltage of 0.69 volts or less suggests that further investigation into service information might be needed, or substituting a known good PCM could clarify whether the existing PCM is faulty. If the voltage does not meet these conditions, replacing the accelerator pedal module is necessary to rectify the issue encountered. In this step, again, start by turning the vehicle off and jump the SCS line with HDS. Wait over a minute before disconnecting PCM connector A. A jumper wire is then used to connect the VCC4 line at the appropriate terminals of the APP sensor's connector. This action allows you to check for continuity. If continuity is confirmed, the VCC4 wire is in good condition, meaning that you should now check the authorized service information or consider substituting a known good PCM. If there's no continuity, you have identified an open circuit in the VCC4 wire, which requires repairing to restore proper function to the APP sensor system. For troubleshooting step 8, turn the vehicle off and disconnect the APP sensor 6P connector. Switch the vehicle back to the on mode and measure the voltage between the specific terminals of the APP sensor connector. If the voltage reaches around 5.0 volts, this indicates that the accelerator pedal module needs replacement to rectify the problem effectively. Conversely, if the voltage is not as expected, you should proceed to check for other potential failures in the APP sensor system, guiding your next steps in the diagnostic process. In the final troubleshooting step, you will again turn the vehicle off and jump the SCS line with the HDS, then allow over a minute to lapse. Disconnect the PCM connector A before jumping the specified terminals necessary for this test. Following this, the continuity of the SG4 line must be verified. If continuity exists, the SG4 wire is functioning properly, and you may need to refer to any authorized service information or think about substituting a known good PCM. However, if no continuity is found, it signals an open in the SG4 wire that needs to be repaired so that the APP sensor can operate correctly, ensuring no communication issues with the PCM. After all necessary repairs and replacements related to DTC P2121 have been completed, it's vital to conduct a final verification step. Begin by ensuring that all connections, especially at the APP sensor and PCM, are secure and free of corrosion or damage. Next, check the system's functionality by performing a test drive of the vehicle, particularly monitoring the accelerator pedal response during various driving conditions. This will allow you to confirm that the engine behaves appropriately, with no hesitation or warning lights present. Finally, clear any DTCs using the HDS to reset the system, allowing it to recheck all parameters before returning the vehicle to the owner. To prevent the recurrence of DTC P2121, maintaining the integrity of the wiring and connections associated with the APP sensor is crucial. Regular inspections should be performed to identify any signs of corrosion, wear, or loose connections. Ensuring that wiring is secured and protected from physical damage can significantly reduce the potential for faults that may lead to erroneous readings. Additionally, keeping all components clean and well-maintained will support reliable sensor performance over time. Implementing these preventive maintenance strategies can help extend the lifespan of the APP sensor system and promote better vehicle reliability. In conclusion, dealing with DTC P2121 requires a systematic approach to troubleshooting, ensuring accurate voltage readings from the APP sensor. Following the detailed steps outlined can help identify any potential faults in the sensor, wiring, or the PCM itself. It's critical to confirm the problem and execute each diagnostic step thoroughly to find the specific issue. Once addressed, undertaking preventive maintenance measures can help avoid reoccurrence, ensuring smooth vehicle operation. Prompt attention to this DTC is essential to maintain performance, safety, and driver confidence. Please like and subscribe to the channel. See you next time.